Hello dear friends, welcome to another video of the Never Do Through the Way What You Can Do Through the CLI. I am Vangelis Prokopiou and today you are watching Converting a Python Script to Rust Part 5, Benchmarks and Impressions. So today this will be the last video regarding this mini-series of converting a Python script to Rust. I have finished this conversion to about 80% because I did not implement some things that I will not be needing in the future. And I want to talk about the benchmarks, as I said, and the impression I had while doing this conversion and writing this Rust code. So I have created, I will show you the two scripts. This is the Rust script here, and I will show you the overview of what the script does. So we don't need this is not implemented, in order for you to understand what is going on. So we start here. We start the execution, and what we do is that we load a collection of nodes, and we want to build a unique list. So we have duplicates in here, and in this computation we just check what does the duplicates are, and we filter them out in order to have unique nodes, plus some other stuff, some editing, etc., etc., some property assignments, etc. The next part is to start manipulating the unique nodes, and what we do here is we handle images in dynamic content, we handle files in dynamic content, we handle images in the body, we handle links in the body, and we handle external links in the body. So we extract these media files and these links, etc., and we do what we have to do with them. We either create new media items for Drupal, especially. This will end up being used in Drupal, or I do what I have to do with the external links. I change the URL to point to the internal site, etc. The next part of the computation is to clean up the body of various unclean parts with regexes, like cleaning nested divs and cleaning other things that I don't need, like styles, etc. The next part is to distribute the nodes to specific node types, articles, events, as you can see here, tenders, recruitments, etc. These are project specific, but we have to do it. And then the next part is that I start exporting the JSON files. So everything we have calculated here will be exported to JSON. And then we have some tests in order to be sure that we did not break something while we change things. We do not break the output of this of the body of the nodes or of the images. As you can see, I have expected the image IDs, and I make sure that indeed these images line up. So this is the Rust part. Let's check out quickly the Python part, which is again the same thing. I have another Python script, which is the actual script that I use, and I created this clone, and I removed all the things that do not exist in the Rust code. So we have two identical scripts. If we check the overview here, we will see the same things, that the execution starts, we create unique entries, and we do all the stuff that we did in the Rust code. So we have two same scripts regarding the things they perform, and one is Rust and the other is Python. So let's get into the benchmarking. So let's come here and we will start with Python. So what we want to do is we want to time the execution of the life array cleaner script. So let it run. You will have to wait with me for the execution. Let me zoom in a little more. And we have 16 seconds running. Let's rerun just to have a second timing. (16 seconds, 0.5, 16 seconds, 0.7 was the first time. So we are around 16 seconds, let's say. So now let's try the, and as you can see, we have some output here, some statistics in order to check the two scripts. So now let's check the Rust code, and what we will have to do is first of all build it, build release, and then what we want to do is target release life array cleaner, and we want to time it. So let's time this too. So let's run. Okay, the output is 3 seconds, as you can see. Let's rerun. (3 seconds, 0.5, 3 seconds, 0.3. Let's rerun. (3 seconds, 0.4. So we are approximately to 3.5 seconds for the Rust program. Now, as you can see, the output, we have number of unique nodes is this one, so they match up. Articles is this one, they match up. Events, they match up. So we have a correct Rust program that provides the same output, the same data. And as you can see, the execution time has fell from 16 seconds for the Python script. The real Python script performs some more computation, so it's a little bit more. But this stripped down version is about 16.5 seconds, and the corresponding Rust program is 3.5 seconds. I did not manage to make the Rust program quicker through parallelization, through rayon or through threads, and I suppose this does not happen because the context switching and the mutexes and the locking and all these things finally take the same time with the non-parallelized version. So if I add parallelization, I am still here to about 3 point something, a little less, but I decided not to add any parallelization because I did not gain much stuff. So as you can see, we are orders of magnitude quicker with the Rust code. So this is out of the way, as you can see, and as it was expected, the performance of Rust is blazingly fast. And this is a huge gain that you will get if you use Rust. Now, I want to go into the impressions part. I'm covering the impressions. Let me move me here. So what were the impressions that I had while developing in Rust? What was the overall experience? The overall experience for me is a very pleasant one. I really enjoyed while using Rust, and what I enjoyed was the fact that you are not afraid of changing the program. there is always immediate feedback from the compiler, which of course it's a lot more difficult to make this run in Rust than in Python, but the security that the compiler provides in Rust is something that I really appreciate, because both with this script or with other languages that I use at work or for other projects, it's quite an unpleasant experience to try to refactor the code and then having runtime problems during the execution. For example, JavaScript, there have been a lot of times that I try to refactor something, and I found out later that I had a very serious bug due to the refactoring, because I did not change some other part of the code that was dependent on this refactoring. Now, all this stuff do not happen with Rust, because you have immediate feedback from the compiler that you have a problem, so it makes refactoring and restructuring your program very effective and very pleasant. For example, if we just change this, let's say this type, let's change this type, to an i32 from an i64 and try to compile this program, let's say cargo check, and you will see immediately that we have feedback from the compiler that we expected an i64 and we find an i32. So this kind of feedback, I repeat that I really appreciate it, and it helps me restructuring and refactoring without fear. Plus, it also, let's reset, okay. Plus, this fact that you have so lively feedback from the compiler also helps breaking down the program. This is related to restructuring. For example, I have various modules, as you can see, with various visibility modes and their own static variables, etc. I have, for example, a writer's mode where all the writing to disk happens, all the related stuff that is related to writing is included in the writers. Maybe I will create a reader's module in order to have all my stuff there regarding the reading from the disk, because I also do that, I read from the disk. And this makes the whole structure of the program much more easy to reason about, much more easy to refactor, much more easy to restructure, much easier to be confident about what you do in general, because as I said in the first video also of this series, in Python, also the indentation is an integral part of the program. So if I do this, I have broken my code, and I don't like that. Plus, if I, for example, if I hit Control S in order to save, sometimes an S comes up instead of saving, and this also creates a problem. This breaks my program, but I only understand it during the runtime. Even such small details are very annoying. For example, if you don't have immediate feedback, whereas in Rust, if I do that, for example, if I write S by accident and I try to run this, you will see that I have unexpected token. In other words, the program does not compile, and then I have to search why, and I see this problem, I fix it, and the program compiles again. So even these little things, these small things, these details become very annoying when you develop in such languages like Python or JavaScript or other interpreted languages. So again, to recap, the performance is awesome, and the impressions of developing in Rust were very positive for me, and indeed I don't see myself writing anything else for a larger project, for example, instead of using Python or any other, or Node, for example, in order to write it in JavaScript. There's no possibility that I will pick those languages in the future compared to Rust. Of course, there are some things that I will choose Python to do the task in Python. For example, if I want a quick and dirty script for making web requests, I believe that I would use Python. But other than that, any program that needs more than, let's say, 50 or 100 lines of code, I will switch to Rust. This is my impressions. And I'm thinking of, for example, the example that I gave about web requests. Even this, I'm thinking of creating a skeleton program for my needs in order to have this a parallel iteration for web requests, to have it ready and modify it according to my needs, and using Rust for that too. So this is pretty much what I wanted to share with you. I hope that you find it useful, and I hope that you will think about Rust and how it can help you in your day-to-day job as a developer. That's all for this video. Thank you for listening and have a great day.